Swayam Prabha. Digital India. Educated India.
Hello everyone, today I am going to deliver a lecture on resistance spot welding. It is a welding process where heat is generated by electrical resistance of material. This is the content of today's lecture, that is introduction, then principle of this operation. I will discuss about the equipment used in this resistance spot welding process, then what are the procedure or a step followed in resistance spot welding. I will discuss about the series types of resistance spot welding. I will discuss about the heat generation taken place due to resistance heating. I will discuss about the resistances of resistance spot welding process. That means what are the different types of resistances generally arises in resistance spot welding process. Then what are the important time cycle of this resistance spot welding process. Then its operating variable. And I will discuss about the heat balance concept, then advantage, disadvantage and its application. Okay. So, resistance spot welding is a category which lie in resistance welding technique. Okay. So, before going to discuss about resistance spot welding, first of all we should know what is resistance welding. Resistance welding is such a welding process, you can say it is a oldest electric welding process which is nowadays get its popularity in industry widely. So, resistance welding is one of the oldest of electric welding process used by industry today also. It is developed in early 19th century. This is a process in which the heat required for welding is produced by means of electrical resistance across the two components. This you just keep it in mind. This is the main things required in resistance welding process. So, whatever the welding here is done in between two workpiece, that in between that two workpiece whatever the resistance is there, that resistance help to join the workpiece. What I am telling, understand. So, here the heat is produced by means of electrical resistance across the two components. So, the two component where we are going to make the joining, in that joining portion whatever the resistance is there, that is the most important resistance in resistance spot welding process. Now, you see in resistance spot welding process generally does not require the following component like other welding process. There is required some either flux or some shielding gas to protect the weld pool from atmospheric contamination. In some welding process there is used some consumable types of electrode, but here you will not get that types of thing. That means here generally consumable electrode is not required, here shielding gases is not required, here flux also is not required to do the welding operation. Now, you see here I will discuss about principle of this operation. So, you should keep it in mind, this resistance spot welding is such a process where the main important parameter is heat, pressure and time. These three important parameter is required in resistance spot welding process. Because this welding process is done by combined effect of these three parameter. Okay. So, for the process to work properly, here another things you should keep it in mind, the contact resistance must be higher at the point to be welded than anywhere else. Let us consider here, I am just drawing. This is one piece of material, this is another piece of material. So, these two piece I want to join, I want to make a weld spot or weld nugget, you can say this is called weld or sometime it is called nugget also, just you should keep it in mind. So, let these two piece we are interested to join together. So, here to make this joint or to make this weld nugget, here one thing is very important, that means in this location the contact resistance should be higher at any point to be welded than anywhere else. Okay. Here the resistance is the resistance of material to be welded to current flow, that causes a localized heating in this part, because you see in case of resistance spot welding, generally this current is flowing from a electrode, generally both side you can observe. I will discuss in details in subsequent slide about this thing. You will observe there is used through this, generally current is flowing. Okay. So current is coming from, this is called electrode. Okay, this is called electrode. From this electrode generally the current is passing through this workpiece, then its contact region where we are interested to make the weld, then after that it is returned back to another electron in opposite side, you can observe. So this way generally current is passing. Okay. Now this electrode is connected to power source. So here you see, due to this current flow through this electrode, workpiece or this contact region, there is a series of what happens, resistance you can see. So wherever will be the resistance due to current flow, there will be some heating, correct? There will be some heat generation, because we know according to Ohm's law this voltage is directly, or the V is equal to IR, correct? So wherever there will be a we know according to Ohm's law V is equal to your IR. So once you make a constant, that constant is coming, that is called resistance. So you see, and power or generally heat generation purpose, we know power or heat generation is equal to V into I, voltage into current. So if you just put this V in terms of I R, then you will get power is equal to I square R. From here you can observe that wherever there is a resistance, and through this resistance if there is a flow of current, then what happens, there will be a power generation. This power generally we can convert it to heat. What I am telling, understand, because if this power pass through a location for a particular time, there will come some heat. That means power into time is called heat, or you can say energy. So heat is a energy, this energy is nothing here, it is a energy of heat, you can say. So that is why here you should keep it in mind, the resistance which is the resistance of material to be welded to current flow, that causes a localized heating in the part. Okay. So wherever we are going to make the welding, there is occur some localized heating. And another thing, the part are usually an integrated part of electrical circuit. This also you should keep it in mind. So let this electrode is connected to a power source, here is a power source, and similarly this electrode also connected to this power source. So you see, so this power source, from this power source the current is passing through this cable to electrode, then workpiece, then contact region, and after that it is returned back to other side. So here the workpiece itself is a part of this electric circuit. Little bit clearly I am drawing here. So you see, this power source is a part of this, that means this workpiece is a part of this electric circuit. Okay, this you can observe from this figure. Now here the pressure applied in between this contact region through this electrode, and there is used another supporting element, that is called tongue or horn, that I will discuss in subsequent slide in details. By this tongue and electrode, generally the pressure is applied in between these two workpiece to make it contact. Now here another things you should keep it in mind, the required amount of time is very important in this welding process, because we know once this power is converted to heat, so this heat energy we can write as I square R into time required to flow the current through this resistance regions, correct. So this time is a very important parameter in this welding process. Now here you see, that is why here I am written the required amount of times is determined by, so this time which is determined by the thickness of the material, the amount of current flow, it depends on the amount of current flow, and it also depends on the cross section of the welding tip contact surface. Welding tip contact surface, you can say that welding electrode tip with workpiece, that means electrode tip diameter you can say. So electrode here, this is called electrode. So, this electrode, here I am writing little bit, then it will be more clear to you. So, what happens, this electrode, it's look like, here I am drawing electrode little bit bigger way. So, electrode have a tip, this tip have a circular types of cross section. So, you see, so this cross sectional area of the welding tip generally it's also affect the time required during this heat generation. This I will discuss in subsequent slide in details. Okay. And this is the setup. So, here this is called horn, or this is sometimes called tongue also, okay. And this is called a flexible conductor. This is this U shape things is called conductor, which is flexible type, okay. Now, this is the gap between these two horn, this is one horn, this is another horn, you can say. So, this is called horn spacing, or you can say tongue spacing, this you can say. This is called electrode, which I have already told you, electrode. This is called workpiece, this is called workpiece, workpieces, actually two workpiece generally contact together by this electrode, you can say. Now, you see from this is called transformer, because resistance spot welding generally is done by using a transformer types of machine, okay. Now, here this is the contactor switch, you can say. So, that is why here I am writing contactor, and it is generally a single phase types of power source is used in case of resistance spot welding process. Single phase power source, single phase power you can write, and from here to here, from this transformer end to this electrode distance, it has a name. This is called generally throat depth, throat depth. You just keep this thing in mind. So, why I am labeling this thing? Because at least you will understand what are the different part of a single phase resistance spot welding process. So, here you see whatever the electrode which we are using here, this electrode generally made up from copper or copper alloy with some refractory types of material. Why refractory types of material is used with copper alloy? It is generally used to improve the erosion resistance, and also it helps to protect the electrode from atmospheric corrosion types of phenomena also. And this electrode through which current is conduct to the joint. Okay, this is electrode which I have already written here. Now, here electrode also apply pressure by clamping to improve the contact at the electrode to workpiece interface. This you should keep it in mind, and it has a very important function also. Due to this pressure between these two workpiece, it helps contain the molten metal in the nugget, because what happens due to the resistance in between these two contact surface, there is a chance of metal melting, okay, because this resistance spot welding process is also a welding process where the material temperature goes beyond its melting point temperature. It is also a fusion types of welding process. These things you should keep it in mind. So, to keep this molten material in position, what happens if the close contact or this sufficient pressure will not be there, then what happens, it can expulsion out from this region, correct. That is why to help contain the molten metal in the nugget, this pressure also helpful. Now, here you should keep it in mind that the main parameters which affect this resistance spot welding process, which are actually welding current, welding time, electrode force and electrode shape. These things in details I will discuss in subsequent slide. Here I will discuss in more details about the spot welding equipment. Here you see in this welding process, what I have already told you, this is called electrode, this is called electrode, this is called workpiece, and this is called, is a very in details here I am just showing here, it is called foot pedal, okay, or foot pedal. It is used for generally applying pressure. This can be sometimes foot pedal, or it can be manually, means by hand also you can operate this foot pedal. Okay. This is spring for releasing pressure. This is generally a spring system which is used to release the pressure. This you should keep it in mind. Here this is power supply. This is called timer. It is a very important part of this resistance spot welding machine. And here you see there is use, this is called fixed, one electrode is fixed, another electrode generally keeps movable. That is why you can say movable types of electrode. So, one electrode is movable, another electrode is fixed. So, two different electrode is used there. So, you see this movable electrode, generally this motion is controlled by this spring which is operated by foot pedal. This you should keep it in mind. Now, here you can see, here we used a tapping system, or you already in my previous course I discussed about different types of power source, AC type alternating types of power source. There is generally used different one of the power source which is called tapping types of power source. Here in case of tapping types of power source, there is generally tapping system is there. So, this tapping system generally control the supply of current to electrode. If this tapping S is connected to 1, at that time generally maximum power or maximum current can flow through the circuit. Now, if this tapping switch changes position from 1, 2, 3, 4, its means current carrying capacity generally gradually decrease. So, depending upon its position we can increase the current or decrease the current, but you just from this figure you can see when this switch is in or this tapping connector is connected with position 1, at that time generally maximum current is flowing. This you just keep it in mind. See, so this is a resistance spot welding machine setup. So, here you should keep it in mind, what about the power supply. Here we use, this is a AC power supply which is passing through this transformer. This is a transformer, this is transformer. Here you see, here this primary winding of this transformer, or you can say this primary generally has got tapping, and a particular tapping is selected by the selector switch S, which I have already shown you. So, depending upon the current required for the welding operation. And here you can see this is the secondary coil, or you can say the secondary turn connected to two electrodes. Do you see? So, this second one terminal of this secondary coil is connected to movable electrode, another terminal is connected to fixed electrode. This you just keep it in mind. So, once the pedal pressure is not applied, at that time this two electrode is not applying any pressure to workpiece. So, it is generally in loose condition. Once we apply the pressure, at that time generally close contact is taken place. These things you just keep it in mind. That means, when pressure is not applied on the foot pedal, the electrode are kept apart by spring. Now, here you see the sheet to be welded are placed overlap each other. Overlap each other means whatever the plate we are generally going to weld, these two material generally overlap. Overlap means one is lying over another. Okay. Between the two electrode, so this sheet to be welded are placed overlapping each other between the two electrode, and pressure is applied by pressing the foot pedal. Here spot welding is made in between these two contact surface, what I have already told you. Now, depending upon the thickness and composition of this workpiece, whatever the thickness, that means what is the thickness of this workpiece material, depending upon the thickness of this workpiece material and its composition, generally we have to decide what should be the current range. This current range varying in this welding machine, just I am giving you an idea, it is varying from around 1000 ampere to 10,000, even at a more than 10,000 amperes current. That means a huge current generally apply here. This you should keep it in mind. And here the time period is a very critical part in this resistance spot welding process, because higher the time, more will be the heat generation, because in Ohm's law I have already shown you how this time affect the heat generation. So this time is a very critical part. Generally this time which is used, which can be varying from 1/100 second to more than this 1/100 second. That means it is a 1/100th of a second or more time generally used here. And here whatever the voltage is used, this voltage generally is comparatively very less. Here the electrode, the voltage between these two electrode is about 2 volts, whereas the open circuit voltage here is also comparatively less than other welding process. It is around 12 volt. This you just keep it in mind, because this idea you should know. Now here I am showing what are the procedure generally followed in resistance spot welding process, that I am just showing here. How a welding is made, that procedure also you should know. Here you see this welding procedure we can divide into 3 different steps. One is called you see one is called pressure apply. In its first step generally, first we should require to apply pressure. So this is called a stage where pressure is applied. So first of all we have to apply the pressure to make a close contact between these two workpiece. After that, once there is a sufficiently close contact, then we have to apply the current, or we have to pass the current through this electrode. That is called another step that is called current 1 step. In this step generally current is 1. So first pressure is applied, then current 1. After that, once weld nugget is formed or weld pool is formed, then what happens, we have to off the current. So here this step is called current off stage. But in this stage you should keep it in mind, here pressure remain 1, pressure 1. So this third step here in this stage, here though current is off but pressure should 1. So you can see from this first step to third step, this first, second and third step, in every step there should be pressure 1, but only in second stage or second step there will be current 1. At this current 1 time generally heat is generated and oil pool is formed. What I am telling, understand? This you should keep it in mind. And after that, in fourth step we have to release the pressure. This is called pressure released step. So you can represent this is the fourth step. So in this stage we have to shift this workpiece position to another spot region where we want to make another spot, because generally resistance spot welding is consist a series of spot welding. What I am telling, understand? So here what are the thing required to do? Here our electrode remain at a particular location. Generally we move the workpiece. So in pressure released step, that is step 4, here we generally move the workpiece for another position, and what happens, there another spot is required to make. So here one thing you keep it in mind, during this welding operation, here surface should be clean, okay, and here one of the most important thing is accurate control of timing of the electric current and of pressure are essential in resistance spot welding process. What I am telling, understand? This is a very important thing. These things in more details I will discuss in subsequent slide. So resistance spot welding process in which generally whatever the steps we have seen in previous slide, there we observed that there is used generally 2 electrode. One is putting above the 2 workpiece, another one is used to put below the 2 workpiece. So this is one electrode and this is another electrode. This you have already seen. Now that is why you see, so resistance spot welding consists a series of discrete nugget produced by resistance heating, correct? So this nugget is, for forming this nugget, or you can say this is called nugget or weld. What are the things required to do? Here generally 2 electrode we have to put both side. This is generally conventional types of resistance spot welding. So here the main thing require, we have to have a possibility to access both the surface, what I am telling, understand. So, that is why spot welding usually require access to both side of the workpiece, you see this side as well this side. But what happens, this instead of both side, generally we can use single side types of welding process, where only if there is only single side accessible, that case also we can use resistance spot welding, and we can do resistance spot welding where generally one workpiece surface or one side is sufficient. Okay. So, to do this welding process, there is used a technique that is called series welding resistance spot welding process, or this is called series welding resistance spot welding technique. Okay. Where generally one side of the workpiece is sufficient to do the welding operation. Okay. That means spot welding usually require access to both the side of the workpiece, but this can be accomplished from one side also by using a technique which is called series welding technique, which I am showing here. You see how it is working. Here you see, here this is one electrode we are using, this is let us electrode 1 and let this is electrode 2. So, through this electrode, let this electrode generally, let this is the power source. So, here you see, so from this power source, this power is coming to, or power means here current, this current is passing through the cable to electrode, then electrode to workpiece. After that, this workpiece again is goes to by using some backing bar, or sometimes backing bar also not required to use, there this current flow through the lower workpiece itself. So, you see here I am just showing where generally current is passing through electrode to workpiece, then workpiece to this backing bar, after this backing bar to again workpiece, and it is returned back to another electrode. After that, it is generally coming back to this power source. So, these types of system where generally you see in first case there will be one nugget, and in second case also where the electrode is using just below that electrode there will be another nugget. So, two different generally spot we can make simultaneously by these types of series welding technique at a time. So, that is why here you see here current passes from one electrode on the face of the work through the work to produce a weld at the interface, you see at the interface of the workpiece. After that, once it just return back from this workpiece to again for a second electrode, at that time also this second spot or second weld is formed at this workpiece interface. So, in this way generally two different types of spot we can make at a time by using a series welding technique, where the electrode is accomplished from one side only. Now, resistance spot welding, first of all we should know what are the different types of resistance and where it is formed. So, you can see in a resistance spot welding there are 6 different point, or you can say 6 different major point of resistance in a resistance spot welding component. What is this 6 different types of resistance, that I am just showing here. Here you see this is in electrode, there will be some resistance. So, let this is I am representing resistance 1. Now, you see depending upon this size of this, what it is called size of this electrode tip diameter, there can be some another resistance. So, that I will discuss later one. So, first is the electrode resistance itself, I am representing R1 let us. Then another one is this top workpiece resistance, let this is R2. Then there will be some resistance in bottom workpiece, that is let us R3, and there will be some another resistance in second electrode, that is R4, and in contact region, here this contact region also where is the welding is made, there will be another resistance, let that is R5, you see. So, these are the 5 major resistance component here you can see, and another resistance component is also there, that is the resistance in between this two contact surface region. Contact surface region means electrode is contacted with workpiece, at that position also there is some resistance, let that is called resistance 6. So, these 6 different resistance you can observe in case of a resistance spot welding process, correct. So, in this to contact surface, here one resistance you will get, here also we can get another resistance in this contact between this workpiece and electrode surface. So, 6 different types of resistance component we can get here. Now, here this resistance generally connected with power source in such a way, these resistance are in series. So, I will discuss in details how this resistance is varying in resistance spot welding process. Like you see, this I am drawing here, then it will be more clear to you. This is this axis represent the resistance, and this axis represent the electrode position and all. So, this point is 0 resistance. Now, you see in electrode, generally throughout the electrode there will be a constant resistance which I am drawing. Just here I am just drawing, this is the thickness region, this is another thickness region, and this is the interface region. So, you see how this resistance is varying, that I am showing. So, you see, so resistance we can represent till the contact surface. In electrode the resistance will be constant, this is your R1. So, once it come to the contact region, here suddenly resistance increase. Okay, so first resistance here to here is your R1 resistance. After that, due to contact surface, here the resistance will be high. So, once it just passing through the workpiece, in workpiece generally as it is a metallic component, here again we will get some less resistance. Here we will generally get some less resistance, that I am representing in this way. Let us say the resistance is decreased little bit, but once it comes to the contact region, in this point generally a sudden hike of resistance will be taking place. What I am telling, understand? So, you see how the resistance is coming. So, this is R1 and this is, you can say this is R1 plus, here you see R6 due to this contact point, and when it comes to the workpiece in this region, generally the resistance is little bit decreased, and after that generally you see once it comes to the contact point, at this contact point this resistance is very high. So, similar things happen in this side also, like till the workpiece, here the resistance will like this, after the once it come to the contact, here the resistance will be high, after that again it is decreasing, and at the interface it will be very high. So, you see how the resistance is varying in a resistance spot welding process, that you can observe from this figure itself. What I am telling, understand? So, this axis, this horizontal axis represent the magnitude of resistance. So, how a resistance magnitude varying in electrode, contact surface and nugget zone, everything here I am showing. Now, due to this variation of resistance, as this resistance are in series, you see this resistance are in series, that is why depending on the position of this electrode, interface and all the things, this once it flow the current through this resistance series region, then what happens, your temperature also is varying. How the temperature is varying, that I am just showing here. Okay. So, here what we observe, that how the resistance is varying in resistance spot welding process. So, we observe that initially you can see I have already drawn in previous slide. So, initially this is due to the resistance of this electrode itself, then after that once it come to the contact, here sudden rise of resistance is there. Once it in workpiece, as it is a comparatively less resistance than the contact surface region, so here some resistance will be decreased. After that once it come to the contact, here again further resistance will increase. So, this way generally you can get the resistance diagram of a resistance spot welding process, that you can easily see from here. Okay. Now, corresponding to this resistance, how the temperature is varying, that also we should know. Here you see this is called resistance and temperature distribution curve for resistance spot welding process. So, as this resistance, this R1 resistance, here as this resistance are in series, that means R1, R2, R3, these are the resistance which are in series, you see. So, what happens once resistance are in series, then what happens once the current is passing through this, temperature also due to this series effect, this resistance also increase once it move from 0 to R1, R2 regions, it is gradually increasing types of phenomena you can say. Due to this increased resistance, that temperature also gradually increase. So, here the temperature how it is varying, that I am just showing here. Let this is your workpiece region. So, here you see this temperature generally due to this series effect, this temperature of the electrode gradually increase. Okay. After that, once it come to the workpiece region, at this region generally due to the high thermal conductivity workpiece material, here generally the temperature is little bit decrease. After that, once it come to closer to the contact surface region, that means contact surface means this R3 region, due to this what happens here, high temperature will rise. So, you see this way generally you can draw the, on other side also similar things happen, that means gradually will increase the temperature, here little bit decrease, and at the contact surface here is very high. Let this is a steel types of material, here I am just drawing how this is rising, then it will be more clear to you. I think it is clear to you. So, you see, so this is the due to this resistance heating generally what happens, these types of temperature also varying. So, here the temperature goes at the tip of this contact region, here temperature goes generally above 1500 degree centigrade temperature for steel types of material, because it still have a melting point temperature which is closer to this 1500 degree centigrade temperature. It generally approximately 1500 degree centigrade temperature. So, you see the tip temperature is coming, how much, that I am just showing here. So, how the temperature is varying, that you can observe. So, this maximum temperature which you are getting here, that is generally coming at the contact surface region, where the material is melting and where the weld pool is formed or weld nugget is formed, and welding is done in that location and makes a spot types of joint. This you just keep it in mind. Now, how the heat is generated, this I have already told you, just here you see. So, we know that voltage is directly proportional to current from Ohm's law, we know. Now, to make it equal, we know we are using generally a constant term, that is called resistance R into I, you can write. So, V is equal to IR, you can write. Now, we know power is equal to your P, that I am writing. Here we have written power is equal to A's here. So, A's we know that V into I. So, you see, so this V into I, how the heat power is coming, that I am just showing here. So, this instead of V, if you use IR, which I am showing in equation number 1, so we can get IR into I. So, here IA square R term is coming. So, this way generally heat power is generated. Now, here you should keep it in mind, as the current flowing through the circuit is constant. So, this heat generation in different location is depends on its resistance value, this resistance. So, resistance is a very important parameter. So, higher will be the resistance, higher will be the heat generation. So, higher will be the temperature. That is why in previous slide I have already represent in details how the resistance is varying and how the temperature is varying in different zone of a resistance welding sample. Okay. Now, here you see this resistance as I is constant here. So, you can say that this power A is proportional to R, this you just keep it in mind. Now, how this power converted to heat, that I will discuss once the time factor will come, that I will discuss in subsequent slide in details. So, that is why before going to discuss about the effect of time, here generally in resistance spot welding technique, the time cycle of a resistance spot welding process is a very important process. This time cycle generally categorized into 4 different steps, you can say, or 4 different part. One is called squeeze time, here I am showing. This is the total time, let this circle represent here, let this circle represent the total time of a resistance spot welding process. So, here some portion which is required for holding the workpiece, you can say. So, this is generally here, this I have already shown in previous slide also, here generally pressure is applied, before pressure is applied here. So, you can say to hold the workpiece, generally this pressure is applied here. This pressure, initial pressure applying time is called squeezing time. Here this time between the pressure applied and the weld, that means in this time it is generally to holding the workpiece together closely, this squeeze time is applied. it is generally within a range of around complete 1/8 of the complete cycle time, you can say, around squeeze time. So, after that generally we apply the current here, you see. So, once current is applied, at that time generally your heating is so current 1, heating is 1. So, this is called generally heating time. Here you can say this is called heating time, at which generally your material is heated and material melting is taken place and whirlpool is formed. So, this is called heating time. Second time step you can say heating time, which is called weld time, which is generally used to heat the material and do the welding operation. Okay. So, after that we generally off the current. So, here you see this is current off, which I have already told you. So, at that time current is off, but at that time pressure remain on. So, that is why this time is called hold time. So, some hold time is required to make the molten material solidified, you can say. Otherwise, if you will lose immediately after off the current, then there is a chance of splashing out of this molten material from that region, or what happens, removing the molten material from the region. So, there can be chance of defective types of oil. That is why some hold time is required. So, in hold time only pressure is on, but current is off. Okay. So, after that for next spot welding there is required to off the machine, that is called off time. At that time generally electrode separated to permit moving of material for next spot. Okay, this you just keep it in mind, this is called off time. So, these are the time, how much proportion of time is involved for this resistance spot welding process, that I am showing here. You see this proportion also you can observe from this figure clearly. Now, we will discuss what are the different types of process parameters generally used in resistance spot welding process. These are the most important process parameter which are used in resistance spot welding processes, like time factor, pressure, then electrode tip size, then surface condition. So, here most important process parameter is time factor, because you see in case of resistance spot welding process the current value varying from some 1000 to 10,000 or 20,000 ampere. So, that is why for this much of current, what happens, if there is a unbalance of time factor, then what happens, our welding can be defective one. That is why it is a very important factor in resistance spot welding process. Okay. Actually, you can say resistance spot welding process time is the only controllable variable, which is the most important parameter in the resistance spot welding process, that you can say, because to get a good weld quality this time factor is a most important. How these things little bit I am just discussing. So, what we observe that heat power is equal to, we got as I square R, correct. Now, to convert this unit is what its unit, this is a power. Okay. Now, to convert this heat power to heat energy, generally there is coming in this time factor. So, I square R into time, because you know power into time is energy. So, this time is a very important factor here. So, you see now if you just incorporate here the efficiency of this welding process, then what happens, there is coming a efficiency term here. So, this heat energy is equal to, you can represent as eta I square RT, where this time factor is coming whose unit is joule. So, you see if time element is too long here, then what happens, the base material in the joint may exceed the melting point of the material and even boiling point of the material. So, there is a chance to cause faulty weld due to gas porosity. What I am saying, because once the material temperature goes above melting point and it is vaporized, then there is a chance of formation of vapor gases. So, that can interrupt in that region, which can create gas porosity. This you should keep it in mind. So, we have to control that joint temperature by controlling the time factor. What I mean, it should not be vaporized there. And if the time is not controllable, if the time is high, then there is also the possibility of expulsion of molten metal from the weld joint, which could decrease the cross section of the joint and weakening the weld. Because you see, two workpiece generally connected in this way. Now here the material generally due to heating molten is taken place. Now if this molten material expel out from this region, then what happens, there is a chance of decreasing the thickness in that region, correct? There is a chance of decreasing the thickness of the in this region. So you see these types of thinning action can be taken place due to expel out the, or you can say due to the expulsion of molten metal from this region, or weld quality will be a defective types of weld. Okay. Now the another parameter which is called pressure, this is also a very important parameter, because here this pressure is primary purpose is to hold the part to be welded in intact contact at the joint interface. Okay. Here one thing you should keep it in mind, high pressure if we have, then what happen, there will be very close contact. So once there is a very close contact, then higher the pressure, you can say contact resistance will be less. So higher pressure, high current is required, and conversely lower the pressure require less ampere for resistance spot welding machine. If the pressure will be lower, then what happens, in that region your contact will be loose type, so resistance will be more, so less current is required to pass through this region. But what happens, this pressure should be optimum, higher pressure or lower pressure is not preferable, there is a optimum pressure range, that you should keep it in mind. Okay. Now electrode tip, it is another important parameter you see. Generally this electrode tip is either made by using copper, or it can made by using some copper and ceramic types of material, or you can say refractory types of material. Okay. Now the purpose of this electrode tip is to conduct the weld current to the workpiece and conduct heat from the work surface. This you should keep it in mind. That the Resistance Welder Manufacturing Association generally classified this electrode tip in two different groups. One is called Group A, another one is called Group B. Group A, which are generally made up from copper based alloy, and Group B is made by using refractory types of metal. Okay. Now this Group A generally further classified by number, like you see this Group B A generally further classified in another 5 different category, which is called Group A Class 1, Class 2, Class 3, Class 4 and Class 5. So here one thing you should keep it in mind, this Class 1, Group A Class 1, which have a generally conductivity which is closer to this copper alloy, that means you can say Group A Class 1 electrode tip, it has a composition which is like pure copper. Now if the number increase, that means from 1 to 2, 2 to 3, 3 to 4, generally this electrode tip hardness and its annealing temperature value increases, and its thermal and electric conductivity decreases. What I am telling, understand? So because some alloying composition generally added there, for that generally its hardness and what is it, annealing temperature changes. That is why higher the number, higher the hardness value, but once hardness and annealing temperature value increase, but what happens, its thermal and electrical conductivity decreases. This you just keep it in mind. Now electrode tip for Group B types of electrode. These Group B types of electrode further classified into another 5 different categories, that is called Group B with some class, like Group B Class 10, 11, 12, then 13 and 14. Now here this Group B electrode tip generally made by using some refractory types of alloy. This refractory alloy generally it is a sinter mixture of copper and tungsten. Generally this Group B composition are sintered mixture, that means powder of copper and tungsten composition. By this generally this electrode tip is made. The electrode tip is made means how this electrode tip is coming. You see this is the electrode, you know. This electrode tip, which is made by using this copper and tungsten types of sintered mixture. Okay. Here also you should keep it in mind, this Group B Class 10 which have a conductivity which is around 40% of the copper metal. Now higher the number, that means higher the class, that means from 10 to 11, its conductivity generally decrease. So, in this class the conductivity of electrode tip, that is group B 1,4 has the lowest conductivity than other class. Okay. This is used rarely actually in resistance spot welding process. Now, electrode tip size. So, this electrode tip, higher the electrode tip, lesser will be the resistance, you can say. Here I am just closing my lecture. From next lecture, because I have some other part in this topic, so I will continue rest of the part of resistance spot welding process in next lecture in detail. Okay, because this resistance spot welding is containing 2 lecture. So now I am closing my lecture here, because from this part onwards I will continue in next lecture in details, where there will discuss about these different types of resistance welding parameter details, and also I will discuss what are the different categories of resistance spot welding process in details. So that I will discuss in next lecture. So thank you.